All right, so we are going to review slope a little bit here. We're going to jump ahead to 2-3. We're going to break chapter 2 up into two parts. So we're going to do sections 1, 3, and 5 as our part 1, and then we'll go back and do all the rest after our part 1 test. So looking at slope, this is just slope. So we're going to eventually look at equations of lines, but just looking at the rate of change. So looking at this situation right here, we could think of them as ordered pairs, or we could think of them as a table for, let's say this is every 2 minutes, something goes 12 feet. Okay? Maybe it's a bug or something. I don't know. A worm. Okay, so we want to figure out what the rate of change is. Okay, what's another way to say the rate of change in this situation? Yep. Okay, so on the top one, we're adding 2 each time, and you're adding 12 on the bottom one. Okay. Yep.
That, or you could always do times it by 6, so 2 to 12 is times by 6, 4 is 24 is times by 6, and so on and so forth.
Okay, that's another pattern. So if you look vertically, we're multiplying by 6 each time. Would the rate of change be comparable to maybe the speed that this object is going? Okay, so if we're looking at the rate of change, how would we do that? Which one would be, what pattern would we be looking at? We're going to have to do some subtracting. So let's just go from here to here. Okay, so if we take our distance and we subtract our time, we get this number that she brought up as 6. Okay, that's the rate of change. Okay, so for every, how could we talk about this? What would the units be on that? How fast is this going? Feet per minute. Okay, so if we think about it just coordinates, not a table of values. Okay, what's the formula for finding slope? M equals that's here. Now it doesn't matter if you have 2, 1, 1, 2, as long as they're in the same order. Okay, so the order of these does matter. So on the top, when we subtract, we want to subtract the y values. Okay, so what minus what? Now if we go in this direction, we have to go in the same direction on the x's or it's going to be wrong. Okay, so you can pick either direction for the y's, but then follow that same pattern for your x values. So then we'll go -2 minus 0. We simplify and we get -6 over -2, which is +3. Okay, so that's the slope between those 2 points. This one, let's just say we subtract this direction. So our slope is going to be 12 minus 2, 8 minus 3. We get 10 over 5. Now the slope isn't always going to end up being an integer. Sometimes it's going to be a fraction. Questions on that? Anyone still need this? Okay, a couple people. So that formula I do want you to memorize just because it's something we're going to use a lot. Subtract the y's on the top, x's on the bottom. All right, so we have this formula. Let's rewrite it right here. We have y2 minus y1. Again, the numbers don't matter as long as they match here. Okay, but what's another way to think of slope? Maybe some words. Okay, so it's the rise amount over how far it runs in between 2 points. So sometimes it's easier, especially if you have a graph, just to count that. Okay, so we have to find two locations that we know for sure where it's going through. So I'm going to pick right here. Why would I not pick this point right here? Yeah, we don't know exactly what number it's going through, but it does look like if we go here, it's going exactly through that point. So if we count the rise and the run, so the rise being this amount, and the run is this amount, what two numbers do we have? What's the rise? Now, how much is each blue line? Okay, so each blue line is 4 units. So what is the rise, that green number? 16. Okay, what's the run? How long is the red line? 28. Okay, what's that simplify to be? Okay, that's the rise over run. Questions there? Last way that we're going to figure out the rise over run. Okay, in an equation, which value, let me back up. What equation do we typically write lines in? Y equals mx plus b. Let's write that over here. Which one is the slope? The one that has the x attached to it. So what are we going to have to do to this equation right here to figure out what the slope is? Get y by itself. Perfect. Okay, so if we do that, first we'll move this. So we got negative 4y. How should I write this? Why do we want to write it in that order? Yeah, then it matches our slope-intercept form over here. Put the x term first. Okay, now what? Divide everything by negative 4. And now we need to simplify. So this is now y equals, what does this simplify to be? Okay, let's have a really good discussion about this. First, tell me what this is. 10.5? Okay, everybody needs to pay very close attention to this. I heard you saying these answers. These blue numbers right here are my pet peeve. What did we say slope was up here? What two words? Rise over run. Where is your rise over run on 1.5? You don't have one. Where's your rise over run on 1.5? We're not going to go up 1.5 and over 1. Okay, we're not going to go up by decimals or fractions. You need a number over a number or an integer. Okay, no mixed fractions, no decimals. Makes my skin crawl. Okay, you need a fraction. Number over number, even if it's improper like this one. Okay? Now, other teachers may not agree with me, but this is just how it's going to be in this class. So, it is 3 over 2. That's what negative 6 over negative 4 simplifies to be so that you have a rise over run. Now, on these problems in the homework, don't stop here and just say that's the slope-intercept form, because what they're asking for is the slope. So, once you get here, what is your actual answer? 3 over 2. is your answer. Okay, so all of the problems are just asking you to find the slope, whether it's between 2 points using the equation, looking at a graph and counting rise over run, or solving for y and getting y equals mx plus b. Questions?